Gentlemen, we're going to attempt to do a problem here that is very similar to the web assigns that I'm asking you guys to do. We were doing these kind of problems before spring break, but I wanted to give you another example of how to do one. This is number 8 out of your book. It says find two positive numbers that satisfy the given requirements. The sum of the first number squared and the second number is 54, and the product is a maximum. So the thing I want you guys to really focus in on these problems is they're always asking for some kind of maximum or minimum. And you need to figure out what it is that they want a maximum or minimum of. In this case, we're being asked to find a product that is a maximum. So if I'm trying to find a maximum product, I need a product function. And I'm going to write a function that has two inputs. I'm going to call the first number x. I'm going to call the second number y. But if the product function then would be x times y, and I am trying to find a maximum of this function. So if you guys remember, we're going to take a derivative of this function. We're going to set it to 0, and that's how we're going to find a place where we have a maximum or a minimum. Now, my problem is I've got a function that has two inputs, and taking derivatives of those is not something we'd really want to do. We'd like a function that just has one input. And here's where all that other information is going to come in handy. It says the sum of the first number squared and the second is 54. So my first number I called x. It says the sum of the first number squared. I'm having a little problem here. Come on, squared. Plus the sum of the first number squared and the second number is equal to 54. So x squared plus y is equal to 54. And what I'd like to do is I'd like to use this relationship to get this down over here, this product function, to one variable. So I'm going to subtract x squared from both sides, and I end up with y equals 54 minus x squared. And what that's going to allow me to do is I'm going to rewrite this product function. A lot of operator error here as I learn how to do this. Okay, stop. Just give me a product. There we go. I'm going to write product function again, but I am going to get rid of this y right here. I'm going to rewrite that y as 54 minus x squared, because that's what y is equal to. So I'm going to rewrite that as 54 minus x squared. And so again, I'm trying to find a maximum product. I had a product function, but it had two inputs. I've now got my function down to one input. And that's where you want to do, because now I can actually take a derivative of this. So let's find p prime. And you know what? Actually, let's before we do p prime here, let's make this a little easier on ourselves. And let's rewrite it as 54x minus x cubed. That'll be easier to take the derivative of in that form. So p prime of x is going to equal 54 minus 3x squared. And again, if we're trying to find a maximum or a minimum, the key is to set that derivative to 0. So I want a value of x that will set this to 0. So I'm going to bring my 3x squared to the other side. I'm going to divide both sides by 3. And I've got x, so let's take the square root of both sides. And so we have a maximum when x is equal to the square root of 18. In other words, we know that this product function is 54x minus x cubed. We took the derivative of it. We set the derivative to 0 right here. And then we solved when x is equal to the square root of 18, our derivative is 0. So we now know that when x is equal to the square root of 18, our product is a maximum. You might be asking yourself, well, then how do I figure out what y is? Well, come back over to the left side over here and remember that we know that y is equal to 54 minus x squared. We know that x is equal to the square root of 18. So 54 minus 18, the square root of 18 squared. Well, if I take the square root of something and I square it, I get whatever that something is. And so y ends up equaling 36. So when x is equal to the square root of 18, y is equal to 36, and that is when we actually have a maximum. I hope this helped. I'm trying hard here, guys, to make videos that make some sense, and I'm having plenty of technical difficulties. Plus, during this video, I had a 6-year-old climbing over me, so that wasn't too bad. I hope this helped, and please let me know what I can do to help you.